All right, so I just wanted to, in this video, take a couple of minutes because we've learned three different ways of solving differential equations, and it can be hard to know which method to use. And so I thought it might be helpful to see a differential equation that can be solved in more than one way, and just sort of compare and contrast those different methods of solving it. So we're going to start with a nice example here, just y prime equals y over x. So I could solve this in one way by separating my variables. So let's just do separable. So I think of dy dx, that's y prime, is y over x. Then I divide by y and multiply by dx. I get the natural log absolute y equals natural log absolute x plus c. Then I do e to the left-hand side and e to the right-hand side, and I get my solution. Absolute value of y equals, and be careful, a lot of you guys have been doing this wrong. So this means that you have e to the natural log absolute value x, and the plus c is in the exponent. The plus c is in the exponent. That's really important. And so what that means is you have addition in the exponent, so that's multiplication down below. So we have absolute value of y, oh come on pen, equals e to the natural log cancels out, so I have absolute value of x, and then e to the c is just another constant times a. Okay, now because we have this undetermined constant here, the absolute values don't matter because depending on if y or x are positive or negative, the value of a will just change. So we just get y equals, that's an arrow, we just get y equals ax. And you can double check for yourself that if you did this, it is a solution to the original equation. You can double check that for yourself because think about what y prime is. If you take the derivative of ax and then think about what y divided by x is if you do ax divided by x. So I think you can verify that. So that's one way to solve this, is separable. A second way to solve this, let's just clear everything so I have enough space. The second way to solve this is the second way that we learned, which was a homogeneous differential equation. So I'm going to write y prime is equal to, I'm going to use the substitution that v is equal to y over x. In other words, x times v is equal to y. In other words, take the derivative with respect to x. 1 times v plus x times v prime is equal to y prime. So then, when I come back over to my original differential equation, I can do those substitutions so that y prime, the left side is just v plus xv prime, and the right side is just v. Okay, so let's see if this works. After you make your substitution, then you try to solve it like a separable. So we go minus v. So we have x times v prime, which is dv dx, equals 0. I'm going to then divide by x. So I have dv over dx is equal to 0. And then if I integrate, I just get that v has to equal some sort of a constant, because a constant has a derivative of 0. And then if I remember that v is y over x, you can see that we end up with the exact same solution, y equals c times x. So in the other one I called it a times x, this time I'm calling it c times x, it's the same thing. So you can see that when we did it the separable way, it worked out. When we do it the homogeneous way, it also worked out. The third way that we have solved differential equations is with an integrating factor where we are doing an exact differential equation. And so if we want to make it into our exact form, we want to make it y prime and then a function of x times y and then some other function of x. So I've got y prime minus, I moved that over, so minus 1 over xy equals 0. I'm going to make an integrating factor that is e to the integral of the function of x that touches y. So that's just equal to e to the negative natural log of x. The negative in front of the natural log can be thought of as a negative 1 power inside of the natural log. So we have e to the natural log of x to the negative 1. Canceling e and ln gives us x to the negative 1. The integrating factor is what we multiply our equation by to turn it into a product rule. So we multiply the equation x to the negative 1 times y prime minus x to the negative 2 times y equals 0, because we multiplied by 0. And you can notice that this left-hand side is a product rule. Right here we have f prime times g, and then right here we have f times g prime. So we can rewrite the left-hand side as the derivative with respect to x of f times g. Okay? And that's going to equal 0. Integrating the left side cancels the derivative. Integrating the right side gives me a constant. So I have x to the negative 1 times y is equal to a constant. Multiply both sides by x, and you get y equals c times x. Okay, so some differential equations can be solved in more than one way, and that is okay. What I want you to do is to think about which of those methods do you recognize and try it out in the problem. And if it doesn't work out, just try another one. In this class, we've only got 3 different methods, so if the first one doesn't work, just go down the list and keep trying different ones until it works. If none of them work, then you want to try Euler's method, which we'll talk about at some other point.